In this video, we're going to go over inverse trig functions. So we should be familiar with inverse functions, but here's just a little summary recap. So for a one-to-one function, each x value is going to correspond to only one y value, and each y value corresponds to only one x value. So that's the definition of a one-to-one function. Now this is important because if a function f is one-to-one, then we know that that function will have an inverse function, and it's denoted by this guy here. So this would be the inverse of our function f. Now the domain of our function is going to be the range of our inverse function, and the range of our function is going to be the domain of our inverse function. So if we have this point on the graph of our function f, then this point will be on the graph of our inverse function. Now the graphs of our function f and its inverse are going to be reflections of each other about this line here, and we can see that by graphing those guys. And then lastly, to find the inverse function from our function f, we'll follow these steps here. So we'll replace our function, or our f of x, with y, and then interchange our variables x and y, and then solve for a variable y. Lastly, what we'll do is replace this variable y with our inverse function notation. Okay, so this brings us to our sine function here. Remember, if we want to determine if a function is one-to-one, we can use the horizontal line test. And so here's the graph of our sine function, and if we were to use the horizontal line test, we see that it does fail because it would intersect our graph at more than one point. However, if we were to restrict the domain of our sine function to this interval here, minus pi over 2 to pi over 2, we see that this restricted area would define a one-to-one function, and we can see that by applying the horizontal line test. The horizontal line would only intersect this graph at one point. So on this restricted domain, the sine function is one-to-one, and it will have an inverse. So this brings us to the inverse sine function. So this function here is the inverse sine function, or arcsine, and it's defined, like we said, by restricting the domain of our sine function to this interval, and then reversing the roles of x and y. Now, if y is equal to sine inverse x, this means that x is equal to sine of y on this interval here. Now, the domain of the inverse sine function is going to be this guy here, and the range of this guy is going to be this here. Now the range of the inverse sine function, sorry, it looks like this is blocking this, is going to be the restricted domain of this guy here. That's one of the properties that we saw at the beginning of this video for our inverse functions. So here is the graph of our inverse sine function, or arcsine. These guys are used interchangeably. So let's look at an example here. We want to find the exact value of this expression here. What we'll do is use the fact that if y is equal to arcsine of x, then this means x is equal to sine of y. So we can rewrite this guy in that alternate form. We have y is equal to sine inverse of root 3 over 2. And so in this case, our x is going to be root 3 over 2. So we'll rewrite it like this here. We'll get that root 3 over 2 is equal to sine of y. Now all I want to do here is then find our angle y such that sine of y will give us root 3 over 2. And then we have our unit circle here to help us determine that. Now notice sine of y here at pi over 3 is going to be root 3 over 2. And we also see that that's the case at 2 pi over 3. However, remember our range is going to be negative pi over 2 to pi over 2. So this option here, this 2 pi over 3, is not in our range. So the exact value for this guy here is just going to be pi over 3. Now let's look at our inverse cosine function. So our function cosine inverse, or arc cosine, is going to be defined now by restricting the domain of our cosine function to this interval here, and then reversing the roles of x and y. So if we have y is equal to arc cosine of x, this means that x is equal to cosine of y on this interval here. Now the domain of our inverse cosine function is going to be this here, and the range is given by this here. And again, we know that the range of the inverse cosine function is going to be the restricted domain of our cosine function. And that's given by this diagram here. We have the graph of our cosine function and our restricted domain, and the graph of our arc cosine function. So let's look at this example here. Now we want to find the exact value of this expression. So again, we have that y is equal to arc cosine of 1/2. Now this is the same as this here. Again, our cosine inverse and arc cosine are used interchangeably. Now going back to this here, if we have that y is equal to arc cosine of x, this means x is equal to cosine of y. Now in this case, our x is 1/2, and we'll rewrite this as x is equal to cosine of y. Now what we want to do here is find our angle y such that this is true. So going back to our unit circle here, we want to figure out when cosine of y is equal to 1/2. Now notice this happens at pi over 3, and this also happens at 5 pi over 3. But in this case, our range for our inverse cosine function is just going to be from 0 to pi. So our only value where this is going to be true is at pi over 3, since 5 pi over 3 is outside of this domain from 0 to pi. So we'll just write this here. So we have that our y value is just going to be pi over 3. And then these should actually be brackets since we're including these values in the range. Alright, now let's look at the inverse tangent function. So similar to our inverse sine and cosine functions, we're going to restrict the domain of our tangent function to this interval here, and then reverse the roles of x and y to define our arctangent function. Now, if y is equal to arctan of x, this means that x is then going to be equal to tangent of y. And then, similar to the last two functions, the domain of our inverse tangent function is going to be all real numbers in this case, and the range is going to be this guy. And the range of our inverse tangent function is going to be the restricted domain of our tangent function. Now this is given by our two graphs here. Again, we restrict the domain of our tangent function, and then here is the graph of our arctangent function. Now let's do this example here. We want to find the exact value of this expression. So again, we have y is equal to arctangent of some value x, which is equal to 1 in this case. So this can be rewritten as x, or 1, is equal to then tangent of y. So what we want to do then is find a y value such that this is true. Now looking at our unit circle here, we see that if y is equal to pi over 4, this is going to be true, since sine of this angle is going to be this guy, and cosine is going to be this guy, and tangent is going to be sine over cosine. Now this is also the case at this point here, 5 pi over 4, but again, remember our range of this guy is just going to be from minus pi over 2 to pi over 2, so this is going to be our only angle. So the exact value for this guy is just going to be pi over 4. Alright, so this brings us to our inverse cotangent, secant, and cosecant functions. So they're all very similar to the last ones we looked at. If we have the y is equal to arc cotangent of x, this means x is equal to cotangent of y. And similarly for secant and our cosecant functions. So we'll use this to do the next several examples here. We want to find the exact value of these expressions. So for part A here, first thing that we'll do is rewrite this using this here. So we have y is equal to arcsecant of x, where x is going to be minus square root 2. So we'll just rewrite it like this here. So we'll have minus square root of 2 is going to be equal to secant y. Now, remember, secant is the same thing as the reciprocal of cosine of y. So what we'll do here is then get cosine of y alone so that it's easier to work with. We'll see that cosine of y is going to be 1 over minus square root of 2. So what we did was we multiplied by cosine of y on this side and this side. Then to get cosine of y alone, we divided by minus root 2 on both sides. Now, just looking at our unit circle, we don't have an angle that makes this true. So what we'll do here is rationalize this denominator by multiplying by square root 2 on the top and bottom of this guy. This gives us minus square root 2 over square root 4, which we know is going to be 2. Now, we want to find the angle such that cosine of y is going to equal to minus root 2 over 2. Now, going back to our unit circle, we know that cosine of y is going to be equal to minus root 2 over 2 when y is equal to 3 pi over 4. And we know that this is true because this will be in the range of our secant function, or our arcsecant function, from 0 to pi. So our y value in this case is going to be 3 pi over 4. All right, let's do the same thing for b here. We're just going to rewrite this guy using this here. In this case, our x value is going to be 2. So we have that 2 is going to be equal to cosecant y. Now again, we know that cosecant is a reciprocal of sine. And then solving for sine, or getting sine y alone, we'll multiply by sine y on both sides and then divide by 2 on both sides. We get that sine y is equal to 1/2. And then going back to our unit circle, we know that sine of y, y needs to be pi over 6. So we get that y is equal to pi over 6 because sine of pi over 6 is equal to 1/2. And lastly, we have our arc cotangent function here. We'll use the fact that in this case, x is going to be root 3, so we'll rewrite it using this here. So we have that the square root of 3 is going to be equal to cotangent y. We'll do the same thing that we did in the last couple examples. We know that cotangent is going to be the reciprocal of tangent of y. And we know that this is just going to be cosine of y over sine of y. So in order to get root 3 on this side, it must be the case that cosine of y is going to be root 3 over 2, and sine of y is going to be 1/2. This is because this is the same thing as root 3 over 2 times 2 over 1. These guys will cancel and we'll get root 3. So what we need to do then is find our angle y such that cosine of y is equal to root 3 over 2 and sine of y is equal to 1/2. Going back to our unit circle here, we know that the only angle for this will be pi over 6. So when y is equal to pi over 6, cosine is equal to root 3 over 2, and sine is equal to 1/2. So this tells us our value for y here is going to be pi over 6. All right, now just something to note here, all of the examples we've done so far, all of our answers were in radians. If the question in your homework asked for a degree measure, we would just report the answer in terms of degrees. Okay, so the last example we're going to look at is this one here. We want to evaluate this expression. So the first thing that we're going to do is evaluate what's on the inside here. So what's on the inside is going to be called y, and so y is going to be equal to sine inverse of root 2 over 2. So just focusing on this inside function. Now this looks super similar to the last examples we've done, where we have this form here, which will be rewritten like this here. So in this case, our x value is going to be root 2 over 2. So we'll have root 2 over 2 is equal to sine y. Now referring to our unit circle, y must then be equal to pi over 4. So that means this guy here, we have sine of sine inverse of root 2 over 2 is the same thing as sine of pi over 4, since we just found that sine inverse of root 2 over 2 is equal to pi over 4. Now referring back to our unit circle, we know that sine of pi over 4 is going to be root 2 over 2. So this whole expression is equal to square root of 2 over 2. Now something to note here, for this particular example, we have sine of sine inverse. So in this case, we could have just noticed that these two will undo each other, and our final answer will be this guy. However, in other examples, when we might have cosine on the outside, where we can't cancel the inverse functions, we will have to evaluate it like this here. So I'll just make a note of that. If we have an expression of this form, this will be equal to x here. Alright, so that'll be it for this video.